Okay, we're gonna try this one more time. All right. So all my videos from yesterday did not work. All right. So yeah, we're gonna keep going with this inverse chapter and then the same old thing, but I think you get the idea of how we built this up. But graphing was not so hot on our last test. So I think we should review it a little bit, even though this is created. So why is cosecant this graph? Because cosecant we graph who? Who do we graph? Sine. Okay. And then some people were not doing this right. Even the ones that we had to graph, we didn't have to shift them. The shifting questions were in the multiple choice. Some people were shifting them wrong. So I think they don't know to graph cosecant, they graph sine and then flip it. Flip of 0 is an asymptote. All right. And then same thing here. This keeps going this way. So sine is 2 bowls. All right. So I do got a problem with that because I didn't think cosecant was very hard to do. Or secant. Because really all you do is graph sine or cosine and then flip them. All right. And then the flip of 0 is undefined again, which makes an asymptote. All right. And then flip of 1 is 1. And then the flip of small is large. Flip of small is large. All right. And that's why we get this U here. All right. Kind of tough. And I think I'm just going to go ahead and do this. They don't even have domain and range listed here. We get the idea of why we did this yesterday to get you to understand inverses and the whole idea of restricted domain. Here's what we need to understand for cosecant. The unique y values, again, we want to stay close to the y-axis. I guess whoever made up the rules of the restrictions on what answers have to come from, all right? And we can highlight this and understand that those are all unique y values. If I keep going, then that's a repeat, right? Those are repeated y values, not blank to blank. What are the blanks, everyone? 1 to 1. So we stop there, and then we flip to the other side and say, you know what? These y values are unique because they're negative. But if I go over this hump, then that is not 1 to 1. So there is the end of the unique y values. I see why that AC teacher went nuts. ACT. Did I say ACT? Anyway, when I say inverse, you say switch X and Y. So what does a vertical asymptote become? Becomes a horizontal asymptote. And then it is kind of hard. I didn't practice this, but I know what I'm doing, but it does take me a minute to think about it. So what I do is I do whatever, whenever I say inverse, you say switch X and Y, that's what I do. I will go blue. So pi over 2 comma 1 is now, let me get a y-axis here. My bad, dogs. All right. So when I say inverse, you say switch X and Y. So this is now, let's go over here and say 1, and then let's go 2, and let's say pi over 2. And then what I'm going to do is like right around 0 comma, let's say 4. So right around 0 comma 4 is 4, 1, 2, 1, 2, 3, 4, comma, right around 0. So 0 comma right around 4, and then 4 comma right around 0. Oh, sorry, I never graphed this. Okay, so then this is this part right here. Okay, really strange. I got it stretched out because I went by 2's on the x-axis there. So would have looked more U-ish if I wouldn't have done that. Then when I go over here, it's negative pi over 2 comma negative 1, which is now, sorry, I'm trying to get my negative 1 comma negative pi over 2. That's a pi. And then this one goes, yeah, right? And then just looking at this point right here, which we'll count that at kind of negative 4, almost 0 comma negative 4 means negative 4, 2, 3, 4, almost 0. There's that asymptotic behavior. So I'm only graphing the legal parts of the inverse of cosecant, not all the other parts that we'd have to delete anyway. So we'd have a vertical asymptote at x equals pi, and then this u would continue and this u would continue, but then it would fail the vertical line test. And again, mathematicians hate non-functions, can't stand them. You don't want to see them, all right? So anyway, that's that. And then we had some real problems with this as well. This was cosine's graph, the cosine kid. We are just starting this with the A-Bers. Actually, I think I did with your, no, maybe not. I think I used verbatim the honors notes, but I actually put a picture of the Karate Kid in their notes for tomorrow. Cosine kid, right? By the way, the old I'm going to bring this up again. The old Karate Kid, not the new one with that moron that wore a house on his head. Anyone? Anyone see the house on his head? Come on. What? Look at me. I need attention. I mean, give me a break. Anyway, getting social here. A house on his head. Huh? A castle. Sorry, it's more than a house. She was impressed. It was a castle, Mr. Rez. All right. Okay. So anyway, oh, this is a topic of discussion now. All right. What's the matter? Is everyone okay? Okay. Now here is the x-axis. We're wrong. Here's the y-axis. Anyone catch that? Okay. And then where are the unique values happening? Right here. So starting to the right, and then keeping going in order to the right. Oh, sorry, and I forgot to put the domain and the range up there. I'll do it after I do this one and get this done. So that is our restricted domain to get my unique output values so that this function is one-to-one, so that when I invert it, I have a function, which is what mathematicians care about for some reason. All right. Anyway, I just find it kind of weird, all this stuff. So I'm going to start my y-axis. Sorry, I keep doing that x-axis a little bit lower because I know I'm going to be graphing above it only. All right. And then, so I got pi over 2 and pi. I'm going to go by, I guess I went by 2. I don't know what I did. So I'm going to go to pi over 2 and then up to pi for my y-axis. Wish these were a little bit lighter, right? And at pi over 2, I do have that horizontal asymptote, because vertical asymptote's inverted becomes a horizontal. Okay, and then we're going to put 1 and -1 again. 1, I almost put negative. Man, I'm full of mistakes here today. Hope video works today. Both videos yesterday did not compose, so that was fun. Nice wasted time. 0, 1 is now 1, 0. And then almost pi over 2, 4 is 4, 2, 3, 4, almost pi over 2. So we get that picture right there, that u half of it. So notice I just have to do a couple points to get how the inverted curve looks like. That's it. That's all I need. All right. Some of the extreme values. And then, whoa, excuse me. And then pi, -1 is now -1, pi. When I say inverse, you say domain and range exchange or input output. And then just to the right of pi over 2, very, very negative, like -4. So that's -4, 2, 3. I went off the screen, just above that asymptote. And then I kind of stretched out a little bit because I went by 2s. Should be more curved than that, but that's okay. If it kept going, you'd have the u's going this way, and then it fails the vertical line test. This is why we don't do that. Got it? Got it. So now, sorry, I didn't do domain and range. What's the domain of this? Well, actually, I could just kind of look at this and talk about what the domain is. It's the range of this, which is negative infinity to -1, and then 1 to infinity. So that still holds true. And then I'm just going to key off of my restricted to get the range. So what did I restrict my domain to? From 0 to pi, but not, I can't include pi over 2 is still. That's still an undefined value. So now that's the range, which we can see this in the picture. It is from 0. I guess we could do this in a certain way like this to pi over 2, parenthesis, then union that with pi over 2, and then it does include pi. The only reason we can't include pi over 2 is because it's an asymptote. Although you could be asked an inverse question, inverse secant of undefined. That could be a question. And then you'd have to say pi over 2. So I could have an inverse secant of undefined. And you'd have to know that that's where that asymptote is. Okay, so this domain is the range. Same thing. Negative infinity to negative 1. Union that with 1 to infinity. And then this range is, I guess we could go negative pi over 2, wrong. That's a bracket. Sorry, I had asymptotes in my head there. That's a bracket, negative pi over 2 to 0, but I cannot include 0, and then to pi over 2. Okay, so essentially, though, here's what I said. You know, and you could put this up here. Cosecant and sine have the same restrictions. Okay, they really do. So when I have an inverse cosecant question, it's going to be the same rules as sine, and I'll put that on the next page. And our notes are going to be done pretty quick, all right? Because you have the idea of how the structure worked yesterday. Same structure, same idea. And then, yes, what just happened over there? Was there a bunch of things flashing to the right? Anyone see something over there? Anyway, nothing. Anyone's not okay. Everything's all right. All right, and then cosine and secant have the same rules as well. All right, they're tied together. So if I know cosine's rules, I know secant's rules. Here's what's Stinkowitz. Cotan and tan do not have the same rules. It's because of the graph. Look at this. This graph happens from here to here, and guess what? Every single range value occurs between 0 to pi. So cotangent and tangent have different rules. All right, and you're going to have to know that. Again, if you did your homework yesterday, gave you the one thing you had to remember: the restrictions. The questions are easy, unless you don't know what you're supposed to know as far as your unit circle. It's all about the restrictions on this really different kind of concept. Okay, so I can do this real quick. Let's go. I don't know. Colors are meaningless right now. Okay, so I have to go from wrong. I want to lower that because I have to just like cosine and secant. Sorry, I want a little more space up here. So we'll just hit pi over 2 and pi. And pi is where the horizontal asymptote is, and it's also at 0. So y equals 0 in this case. And then pi over 2 comma 0, 0 comma pi over 2, almost 0 comma 3 is 1, 2, 3, almost 0. Right? So look at how I get that. I got that point there because I know how to invert, switch x and y. And then almost pi negative 3 is negative 3 almost pi. See? And I guess I should say these things. When you invert a decreasing function, it's still decreasing after the inversion. When I invert an increasing function, that doesn't apply to that one, but I'm just thinking about tangent from yesterday. Okay, so then we could see the domain. The range of this is all real numbers, which makes this the domain. The domain of this was restricted from 0 to pi, but not including 0 or pi because those are asymptotes. So those need parentheses. Again, this is a restriction for that one-to-oneness to occur. Now we're going to go quick. You know, what did we do yesterday? Did we do ACT yesterday? Yes? Oh, we did a college board that I randomly assigned. So I'm supposed to do an ACT day tomorrow. I might show you. This is going to go quick. I'm going to show you a website after this, and I could start it up. All right, because your homework's gonna. Didn't your homework go fast yesterday? Okay, I hope you said yes. Otherwise, you don't know your unit circle. Blah. Okay, so if you have a positive ratio, all of your answers are going to come from quadrant 1 for these inverses. All right, that's all I can tell you. All right, and then from yesterday, crinkle, crinkle, it's drink time. All right, so what did we learn from yesterday? From yesterday, we had inverse sine in quadrant 4. We had inverse tan is in quadrant 4. And perhaps I'll clean this up a little bit. We should call this negative pi over 2, not 3 pi over 2. So all these answers have to be expressed as a negative clockwise direction. But now we just found out that we also have cosecant comes from this. Same idea. When I have a inverse cosecant of a negative, I have to get my answer from, let me put the word negative in here. I have to get my answer from quadrant 4, and I have to express it this way because somebody said so. But it's because of the graph. That's why somebody said what they said. Hey, the graph does this. Let's restrict those answers to that. Okay, and then our new ones, what did we have in here? We had cosine, if I had inverse cosine of a negative. And now, of course, secant, because it's related. Now I'm going to change colors. What am I doing? Secant of a negative. And now I'm going to change colors because this sticks out like a sore thumb. What's weird is cotangent does not follow the rules of tangent. The only ones that I cannot put together here. So when I do inverse cotan and I get a negative ratio, I must answer in quadrant 2. All right, and that's why we're going to color code that there. They probably have something different in the key of the notes, but this is the main idea. Who never plays in an inverse trig question? 3, never. Okay, never. Now again, I told you, probably the next things that we're doing, George, I see you talking over there. The next thing we're going to be doing is solving equations. None of this will apply. None of it. I'll tell you why. The directions are very specific in those. That has nothing to do with this. This is when you have these questions that stand alone as inverse questions, then you have to follow these rules. Okay? So you got to be able to switch your mind back and forth on that. Oh no. Where's inverse secant of -1? By the way, -1 over, -1 over 1. So really what this says is, this is always the escape if you don't know what you're doing. You should at least know secant is related to cosine, so it's Kixer. This is if you don't have your stuff memorized and you freak out. Like 1 is a ratio for 45s. Oh, but that's only tangent and cotangent. So what do I do about this one? Well, really, the only thing that could happen then is y is 0 because of the Pythagorean theorem. -1 squared plus 0 squared is 1 squared. Where do you get 0 comma -1? What's the answer for that? Okay, so actually, I am thinking about this here. So secant is between 0 and, so it's got to be over here. That's -1 comma 0. So what's the answer? Pi. Okay. I guess that's only one answer. That doesn't even apply to what our restrictions are. The only thing that could happen. So -1 for x, which means 0 for y. This is my escape. I often have troubles with that one, but I know when I have sine and cosine of 0 or 1, I know I'm on an axis. 0, 90, 180, 270, and I don't care. I'm going to keep bringing up degree measures. Everyone okay? Emerson, you fine over there? By the way, where does -2 root 3 over 3 come from? -2 over, anyone? Root, anyone? 3. This is how I'm kind of going back to how I did this last year and all the years past. I would actually get my ratios unrationalized and then no cosecants related to SIR. So this is y over r. And it's over. Who is opposite y? The reference angle. Who is opposite root 3? Is it 30 or 60? Who is opposite root 3, 30 or 60? And I want to throw this quote at me if you don't know that. 1, root 3, 2. Root 3 is the second largest side. The second largest angle is 60. So this is a 60, and then I got to do my rules. This is a 60 in 3 or 4, but the rules tell me I have to do 4. So what I'm doing here is, if you don't have them memorized, if you don't recognize them and just can pop the answer out of your head, this is the recovery. And I tell you right now, some people in my AB class, you want me to read the grades from our last quiz just on the unit circle? Here they come. You ready? This is why I cry at night. This is why I can't sleep. 95, 85, 100, 55, 74, 71, 9. This one's not so bad. Bad example. That's a good class. All right, here we go. 94, 84, 92, 80, 58, 37, 31, 94, 72, 50, hike, 31. What do you do with that? What do you do with that? I can't do anything with that. Nothing. Anyway, what's the answer, Fumble? What's the 60 in quadrant 4? Negative pi. If you said positive, I'd kick you out of this. If you said 5 pi over 3, get out, because you didn't even listen to me yesterday. It's all about the rules, all right? The rules. Follow the rules, like wear your lanyard. Rules. I did it again today. You know, I went out in the hall and I go, I'm not going to be the jerk. Imagine that, right? And I go, I'm going to see how long it takes for me to see 20 people not have their lanyard on out in the hallway. Take a guess how long it took. 2 minutes is correct. Booyah. Awesome. Took me 2 dang minutes. Why? No consequences at Lockport. None. None. By the way, I just told you this. Cotan, -1 over 1. What's this angle measure? We should know this one right away. 45. Well, it's 45. I was looking for, it's a 45, right? And then where do we have to answer this, though, for cotan? This has got to be in quadrant 2. Why? Somebody said so. Just like somebody said, put your lanyard on every day. Rules. Otherwise, you're wrong. All right, so what's the 45 in quadrant 2? So that's what's weird. If this was an inverse tan, let's put that right next to this. Arctan of -1. Well, the answer is a 45 and 4 because of why? Rules. So that one would be negative pi over 4. I want to make this point that cotan and tan don't mesh with each other. All right? They don't. What's the matter? Okay, somebody said something. -2 over, -2 over, -2 over, 1. And then that, why do I keep doing this? It's because r is never negative, right? So it's actually 2 over -1. And then who has a sine? She's like bored. She's like, can you just get this over with? So where, though? 30 in which quadrant? Because of the rules for cosecant. 4, and we must negatize it. It cannot be 11 pi over 6 or you're wrong. And I swear to dog, we are going to put 11 pi over 6 in a multiple choice question. And anyone that selects this gets 0 credit. 0. Okay? I'm not being mean. I'm telling you how you're going to be assessed. I'm being nice. I'm telling you when you're going to get a question wrong. You're not following the rules. Without rules, it's anarchy. Society crumbles. Remember COVID? Anyway, Kixer. So this is r over x. Okay, root 2. What kind of angle measure is this? We should know the root 2 thing is a 45. And then where do I have to answer cosecant? What's the rule say? 2. So what's the 45 and 2? 3 pi over 4. And some people just copy. Hopefully you're understanding. Notice what I'm doing again. 0 over, 0 over, 0 over. And it's 1. By the way, what's cotan? It's related to ticks. So what letter is this top one? Okay, so again, I think this is helpful. I always do this. This is why I'm doing what I do, even though I've done this for years. Like, I don't even think, because I might make a mistake on a guess that I think I have it memorized. Now I know. Where's 0, comma 1 located? Where's 0 for x and 1 for y located? Pi over 2. And cotan is, and even tan, same thing. But it is from 0 to 2 pi, so I know this is pi over 2. Okay, and then, oh, yes. Okay, hold on. All right, so here we go. Now, here's what I hope they have a cotan question in there. Geniuses. This is the biggest jerky question ever. Jerky, jerk store called. They're running out of you. That's from Seinfeld. Anyone ever see Seinfeld? All right, anyway. Okay, so how do I type this on the calculator? Oh, one person in my 5th hour does have this calculator. They have an Inspire, which he does have this button. So he can just type this as is. You don't. So what do you have to type, everyone? Second, no. Yeah, second, but I don't have a cosecant button. I don't know what to do. So I have to do inverse sine, but what's the relationship between sine and cosecant? They are reciprocals. So what do I have to inverse sine to get the cosecant inverse of 1/5? This should be something that you should be able to figure out and not be a big deal. So you got to know, I do not have a cosecant button except for Zach in 5th hour. Oh, Zach got mentioned. All right, so Zach can find the cosecant button, inverse cosecant it, and then he gets his answer, and the calculator will. You can trust your calculator. Remember, one more time. This is 1.57. This is 3.1. You don't have to do this. You don't have to do wrong. Remember, we called this negative 1.57 instead because the calculator will spit out an answer this way, right? Okay, so we expect an answer between 0 and 1.5. What'd you guys get? Huh? 0.20. Makes sense because it's a smaller number. It's closer to 0, so it's a smaller angle measure. You're closer to the x-axis. Boy, I'm struggling here. Okay, then what do we do on this one? Come on, you get it now. Inverse cosine of what? 8/9. Because I don't have a secant button. This is the calculator's fault. I'm surprised the newer TI-84s didn't include these 3 buttons. Because they made the TI-84 right around when they made the Inspire. Then they kept upgrading the TI-84s, but never put these buttons in. Never did. I don't think they still are. Biggest, jerkiest McJerk questions ever. Because do you have a cotan button, yes or no? And I can't wait till Zach next hour has, because I'm going to have him find this button, inverse cotan, and then I'm going to have him tell what his calculator answers. Whereas what we have to do is inverse tan. You know, it's funny, I did the ACT this weekend, and a lot of Lamont people were there. Every Lamont person had an Inspire. And everyone that works or goes to Providence has an Inspire. It's crazy. That's the rules there. But here's the problem. This is why this is a jerk store question. What are the rules for tangent? Where must my answer come from? What are the rules? And it's from negative pi over 2 to pi over 2, right? Aren't those the rules of where the answer comes from? So the calculator is going to give you that, but the question was originally a cotan question. And what are the rules for cotan? I have to have the answers from 0. Sorry, that should be a bracket. 0 to pi. Right? Oh, those are parentheses. Sorry. Right? So I must follow these rules. So now I am going to go to the calculator. I'm going to inverse tan and tell you what you have to do to get this answer right. And then you'll get exactly what Zach gets. I'm here. Hate that there we go. Nirvana. It's 90s day today. Okay, I just want to make sure the internet knows why I'm wearing this stuff. Because I normally dress up so nice, right? All right, anyway. -1, my shorts. And is it root 10? Is it root 10? Negative. So -1 over root 10, that should suffice, right? Right. And then enter. And then, What do I do about that point? Let's say negative 0.31. Well, what you got to understand is that's a anyone referee reference angle. I have to follow the rules and answer this angle because of the cotan rules, which this is a reference angle of 0.31 over there. So how do I answer this question correctly then? What's the math to get this angle measure here? Pi, wrong, minus 0.31. She said 3.14, dealing with a rounded answer. All right, anyway, what's the answer? 2 point what? 83. Is that rounded correctly? Some of you guys really struggle with rounding. You make rounding errors all year long. You do know the rounding errors, right? If this was 2.834, does that round up or down? I feel like I have to cover this because some people are getting this wrong all year long. What does that become? 3? What if this is a 5? Then what does it become, everyone? Do you know how many people miss this? And I get the red pen of vengeance and I'm shaking in my hand. Do I really want to take a half point because this person still doesn't know how to round? Anyway, I just thought I'd spend a moment to teach rounding to the children. Okay, now I love these. Love. Oh my God. What the heck? This is going on forever. Maybe we don't have time to do other stuff. Okay, this is, I love these combo questions. Love them. Okay, so first of all, what's the inverse sine of that? Sine of what angle measures 1/2? Boy, I wish Mr. Samuels would have said this a lot. 30, in which quadrants? Which quadrant must this come from? 4. So what's the 30 in quadrant 4? Negative pi over 6. And then you tan it. You work inside out. Okay, then what's tan of over 6? Remember the hand? Because remember my 30% in AB? They don't even do the hand. They don't do anything. They pick their nose with their fingers. They don't do the hand thing. I don't know what's going on. I don't know how you get a 30% on the last test. But here's a 30, and then tangent is root 1 over root 3. What's root 1 over root 3? Root 3 over 3. But what's the tan of negative pi over 6, which is in quadrant 4? It's negative. So this becomes negative root 3 over 3. Don't know how this happens. You don't know. All right. And now this is another one. An inverse tan of a positive. Good. I'm in quadrant 1. Oh, root 3. Root 3 over 1 for tan. So what angle measure is that on your finger? 60. What's a 60? Pi over 3. And then what's the secant of pi over 3? Well, remember, secant's Kixer, but then I got to flip it. What's the cosine of over 3s? 1/2, because the sine of over 6s is 1/2. So the cosine of over 3 should be 1/2. Okay, but then it's 2. You flip it. And it is in quadrant 1, so it's just 2. So you still have to follow the rules of inversing. Some of these get back. I love this. This is another kind of jerky question. Why am I putting jerky? They're tricky. They're trying to trick you. They're trying to get you. Okay. Actually, I got another jerky ones. I like sine of sine. Watch this. Actually, I'm gonna do 12b and do inverse sine of 4 pi over 3. Jerky. So this one's not as bad. So what's the sine of 4 pi over 3? That's in quadrant 3. What's the sine of an over 3? The sine of an over 6 is 1/2. What's the sine of an over 3? Root 3 over 2. And if you don't have that memorized, you better draw your triangles. Remember I told you about your escape? You got to have something memorized. Side opposite 30 is 1. Side opposite 60 is root 3. Side opposite 90 is 2. And then sine of 4 pi over 3, you got to know that's a 60. Sine is root 3 over 2. And then knowing you're in quadrant 4. You got to do something to survive if you don't have these memorized. That's the quick thing. Like I told if you are sitting there as a BC student struggling, I told my ABers on their test, they should draw this. They should draw 3 pi over 3, 4 pi over 4, 6 pi over 6, and then jumping backwards is 5 pi over 6, 3 pi over 4, or 2 pi over 3. jumping forwards is 7 pi over 6, 5 pi over 4, or 4 pi over 3. And then they should draw this. This is 6 pi over 3, 2 pi. 2 pi, did he say? Never mind. 8 pi over 4. We were talking about him before. And Biggie Smalls. Someone has a Biggie Smalls. She's in a gang. It's a Biggie Smalls shirt on. 12 pi over 6. Jump backwards. 11 pi over 6, 7 pi over 4, 5 pi over 3. Something. Then I told him to draw this. Draw your triangles and put the side measures. Something has to be memorized, not nothing. All right, and then inverse cosine. Inverse cosine of that. Okay, so what's inverse cosine of a root 3 over 2? What kind of angle measure is that? 30 or 60? Which one is that, 30 or 60? 30. And then what quadrant is the rules for cosine? So this is a 30 and what? 2 is the rules. So what's a 30 and 2? What I just drew up there, 5 pi over 6. But I did want to do this one. I'm surprised they didn't do this. Do a sine of an inverse sine of, and then let's say negative root 2 over 2, just to mix it up a little bit. This is the jerky, really jerky questions. All right. No, that's not right. What did I want? No, I wanted the reverse. This one's going to work out fine. Let's get rid of this. Let's say 5 pi over 4. And then we inverse sine that. And then we get an angle measure. Because remember, did it get tricky with it video? Remember when we had to solve this question, cosine of x equals 2 over 4, which is a half. Let's say 2 over 5. And then what do I do to both sides? Not times, sorry. What do I do to both sides? I inverse cosine, and then what happens to these two functions? They cancel. So do you think these two cancel? You think they would, and you'd think the answer would be 5 pi over 4. But you'd be wrong because of the rules. So what we have to do is work inside out and do the rules. This is why I'm telling you this is a jerkier kind of question. I want to cover it right now. What's the sign of 5 pi over 4? Everyone should know that answer right away. Negative, because quadrant 3, and then root 2 over 2. And then when I inverse sine this, wait a minute, I got to do the rules. Sure, it's an over 4, but what quadrant does it have to be in? 4. And what is that answer? Negative pi over 4. So there are two jerky kind of questions involving cotan for sure. Cotan, because it doesn't, you don't have a calculator. So I have to use my calculator to do this, but then I'm made to follow the rules. So the calculator just doesn't spit out the legal answer because of the rules. That is the biggest, by far, jerky question to you guys, because it sets you up for failure. Be ready for it, okay? And understand what I just covered here. And then you'll be fine. All right. The rules are kind of weird. There must be some reason for it. I know I'm besmirching them a little bit, but I'm worried about you. Okay. And then what's inverse sine of root 2 over 3? Oh, no. How do I do this one? And then this is in the no calc section. What? That's not right. Isn't that not a ratio that we have for sine? Correct? It's got to be root 2 over 2. All right. Draw. Anyone? Anyone? Picture of a bunny? No. Draw a triangle. What quadrant must this be in? Obviously, I went this way. So the rules say I have to be in. Like that noise? And then that's Y and that's R because it's inverse sine. So this is negative root 2. This is 3. And then what do I have to use? Something from grade school. The Pythagorean theorem. So I'm allowed to do this. And then what I end up getting is this, which is root 5, right? Isn't that root 5? Root 2 squared is 2. Oh, it's root 7. Set me up for failure there. Why did I listen to him? All right. Root 2 squared is 2, and then 3 squared is 9. 9 minus 2 is 7. Last time I checked. What time is it up there? All right. I guess this is I didn't realize we had all these. I didn't know we were doing the double do questions here. So what this is an angle, theta. All right. So what you're going to do is secant this angle. You never find it. So how do I secant this angle? I access the correct sides. That's it. And what's secant? What is secant? What letter over what letter? R over X. So this is 3 over root 7, which is 3 root 7 over 7. So this was in the no calculator, and this is what I had to do to get the exact answer. Now, if you did use your calculator, you would inverse sine this and got a decimal negative angle measure. Then you would add the secant that negative angle measure, which means you'd have to cosine it and then flip the answer, and you would have got that that ratio's decimal. All right. So did you hear what I just said there? So you would have to cosine the 1 over that answer that you got on your calculator for this one. No, wrong. I said that wrong. I'd have to cosine it, then flip the answer. So it'd be this. Be 1 over cosine of this answer. Because I don't have a secant button, right? And that's what cosine is in terms of secant. But then you get the decimal, not the exact, right? So that's the problem there. So again, drawing a triangle is a key. All right. So I know I besmirched some of the rules. Oh my gosh. I got to do this one too. Oh, take a minute to read that one. Guess what this is? AP. Sine of X rules. Cosine of X rules. Tan of X rules. Find the exact value of the composite function. Oh, so f of x and g of x. Okay, here we go. So if f of x is this, and g of x is this. So that means this first, and then this second. So it's really just reading the question, inserting the functions correctly, and then doing what we just did. Hey, everyone, what's the cosine of 5 pi over 6? Negative for sure, and negative what? Root 3 over 2, because sine of over 6 is a half. That's how we do this. All right, and then what's the inverse sine of root 3 over 2? Negative. What kind of angle is that, 30 or 60? That's 60 in which quadrant? Quadrant 4. Answer is negative pi over 3. So it's really just reading it and then inserting the things correctly. And then this is a triangle draw. So f of x is sine. So I have to inverse sine this negative 2/5. Why is this a triangle question? Because 2/5 is not 1/2, root 3 over 2, root 2 over 2, 0, 1, all the unit circle values. And an h of is tan that. So this requires that I just go ahead and draw again. So what quadrant am I in again? For inverse sine, you're supposed to be in 4. Since I have colors, I'm going to make this like a shady thing here. This is negative 2. This is 5. 2 squared is 4. 5 squared is 25. 25 minus 4 is 21. Square root of 21. So then what's tan of this mystery angle measure? Just accessing those sides. And tan is y over x. So negative 2 over root 21. Negative 2 root 21 over 21. Woo! Okay. I enabled you. On the back of your notes is that homework assignment. All of them are listed there. You just do the ones that are listed there, which are odds, right? Odds. Okay. All right. So that was a lot more than yesterday's. Once we got into the combination of a couple things, and then let's see what video. Are you going to let me have my video or not? Lost both my videos yesterday. You stay.